So the title of this presentation or this session is When Inference Meets Engineering. And the idea was to see how the data science team first solves their inference problem. And then the second part is how do they interface with engineering. Now, every company is different, of course. So that's why we wanted to hear from as many as we can. And coming up with the idea, it was actually Ram, Sabino, and then discussing with Yakov as well. We came up with these two questions, essentially, that we wanted to ask everyone around the Hive to try to answer. And so that's what you will be hearing from the different companies. And we'll try to go through them. We do have about 10 minutes per company, plus minus few minutes. And then we will take, if there are any urgent questions, right after the company presents their contribution, and then we'll have some time at the end. But really, this is meant for when showing or exposing the others of what problems we're solving, especially in the data science space, right? And then two, seeing how other companies have solved like engineering problems, or how engineering is helping the data science team kind of solve their problems, and just exploring that process across different companies. So this is the kind of the gist of what we would like to cover. And with that, so this is the list of companies that we have. And with that, I'm going to call Max first from Boom Jam to kick us off here.
Okay, so we're not as advanced as many of you. This is about the size of our data science team. Like we get just getting started. But we talked with Ram, and it's like, hey, well, you guys are about to have some probably hard problems, so why don't you talk about it? So here I am. You probably heard me, all of you have heard me already maybe, but quickly we are allowing musicians to collaborate. And a lot of the data we're getting is not just fields in the form, we're getting a lot of binary data in form of audio files. Maybe one day video soon. So what's hard with this is you can do a lot of processing on text files. Audio files is at its core just binary data. And so what we would like to do with this data is not just like, well, thank you for sending us data. We would like to do more with it. And so there's a lot of stuff out there, like, processing data, splitting instruments, detecting whatever. But we want to allow to extract maybe, the style of music, like whatever, like we don't want all this to be fully labeled by our users, and whatever data we can bring to them automatically would make us really impactful for the product, like, partly managing audio files, like, oh, this is, I changed this on this file, or I've done this, I've done that, and helping them so they don't have to type out everything. This is a description of the change of what I've done. And so the challenges for us, right, except the fact we don't have anyone analyzing data right now, is it's binary data, it's big, it's like, there's like ways to do fingerprints. You can think about like Shazam, for instance, that can recognize songs, but it's very limited. And so how do you normalize that? Like you just increase this, frequency a bit and all that, and like the binary data by itself is completely different. And so you can't just use checksums and stuff like that. You have to go like a lot deeper. And we want to do it in a way that makes sense for musicians. It's one thing to come out and like you're going to find out a lot of things out there, like generating audio automatically. That's great. You show that to musicians, like, that's crap. I'm an artist, right? So how do you make this really relevant for them as artists? So it helps them, not you showing your tech bro and I know technology and I know algorithms. Like, how does this make music that people like and dance to and buy and go to concerts? And so what we're looking at right now, even though it's like, hopeful, is to be able for us to do like, feature extraction from those audio files. And so it could be like, probably is going to be like fast Fourier transforms, trying to extract like chords and rhythms and beats and all of that, have that to basically turn this huge amount of like binary data. They love sending uncompressed data, turn this binary data into like something that is more descriptive, and then maybe like text files of just like the features, just like arrays of like from that timestamp to that timestamp. This is what I have, like really structured data, and from this being able like to do diffing, like if between this version and that version of this song, this is what has changed, and so allowing them to basically have really useful tools. And so the hard part is also getting label data, right? Like we come in like, hey, you want to build your song on Boom Jam? Oh, wait a minute. Can you highlight every section of your song? Can you tell us the chord progression? Like, I don't have time for this. You're not helping me right now. So we're going to have to come up with ways to have people that are happy to label data or tell us how good it is. So it's critical, right? Like we're not, this is a livelihood. They just want to build, they're not like we're not in a B2B space where you're like, oh, it's going to take you like 10 minutes to do this. Like, no, I won't get out of my way. I just want to upload files. As I say, high user sensitivity to quality. Like you can't just be like, hey, look, I generated some audio and beeps and that. Like, that's cool, right? Like, no, it doesn't sound good. It's not my style. It's not how I write songs myself. Why is this crap? And I'm using their words, right? Like they're going to be they're telling us very quickly already and in their own words. So we cannot just be gimmicky, right? It has to be meaningful to them. And so, yeah, and like other challenges like structured data, and I'm pretty sure you guys are like, I'm pretty sure for Spectrum, like from one place to another, people talk differently. You have like, translation. Well, same way in the music, you have varieties of songs and like pop music and punk music, maybe actually pretty close. Then you go into rap, classical music, like the structures and all of that is very different. So being able to cover most of that will be quite of a challenge. So a solution, we don't have any. We hopes and dreams. The main reason I offer to Edmund, thanks Ram for bringing this up, is to be like, hey, like we're gonna get to some potentially hard stuff, and we're gonna need maybe help from some of you that have been doing similar stuff or more easier, more complex stuff, and help us figure this out, and maybe just even help me hire people when we get to that, and because I don't know how to hire an ML engineer or data scientist. So just wanted to take it out there. We're trying to do some good stuff with this. We're not there yet, but we hope to get there soon. That's it.
So any questions that anyone has before we move to the next talk? Let me ask you one.
Sure.
So for you, what's your ideal scenario for talking about the inference problem? So the input will be an audio file of a song from an artist. What are the labels?
So there. So it goes back to the patent thing that we had earlier. So if you think about GitHub, right? Like you making code changes, you can see the diff. It's text. Actually, diffing text is not that easy. We take this for granted, but for that to be meaningful and useful, it took a long time. But for audio, we can't just show a diff, right? It's just like, cool, I have zeros and ones. What do you want me to show? So we want to be able to be like, oh, well, between this version and that version, for instance, you added 3 bars to that section, right? Or you repeated a chorus or you added an instrument to that chorus. And so today, like artists, the way they do it is just like, oh, this is version final with drums, final, the date final, right? And it's just like, it's literally the way we're just doing software development, like 20 years ago. We're just like putting stuff on FTP and we're like, hey, this is what's in production now. And so we want to bring this kind of like tool that we all take now for granted as developers, but the issue is, like, we can do this kind of stuff on lyrics, right? We allow them to do lyrics. We're not doing diffing yet, but we could. There's like tools for that. But for audio, which is like, you depend on like codec quality, they all have like different sensitivities. So the ideal goal is to be able to build upon these kind of ideas and be like, hey, we're going to treat your music, your files, as stuff that you can, like almost like we treat code, and it's just like the part of the creation process, and like building all those tools so they're not just like guessing or having to annotate or don't know what they're doing. Partly as they collaborate. It's one thing to keep track of your own work. It's another to be like, okay, what did this guy do in that version? What's different? Oh, he left some notes about it, and we kind of want to take it to the next level where we can actually help them and be like, just upload the file. We're almost going to auto-generate what changed. And yeah, that's kind of like the hope, to basically take the manual step out of that.
Very cool. We've done, at Spectrum, we've done some work on audio, so we'll be happy to chat afterwards.
Cool.
Yeah. All right. Thank
Awesome.
you. Thanks, Max. And then
welcome.
next up is Gal. Gal is from Checksum.
So on Checksum, we're also very early stage. We founded the company a few months ago when we're still in the exploration stage. Can you hear me? Yeah, okay. So our problem statement is basically the core of our product. The Checksum product basically does one thing. We track your production environment. We realize what your users do in production and how your software reacts to your users. And then we generate automated tests. So the idea is when you deploy a new version, we repeat all of the actions we saw in production in the last week, for example. And then we're going to tell you if all of those actions work. If they work similarly and very similar to BoomJam, we're also going to generate a diff. So if the action works differently, we're going to show you a diff. But instead of diff in code, we're going to show you diff in user experience or diff in output, which may be a bit more focused and meaningful than just, oh, you changed 500 files. Great. What do I do with that? But how does it impact my user experience? So that's the core of our product. There are a few challenges with it. The first one is break down the user sessions into chunks that make sense to our customers. So if I'm going to tell you, hey, we try to run user session 5234, which is a 2-hour session, and something doesn't work, like what do you do with that? How do you understand what happened? So it's very important to make tests short so you can run them in parallel. When something fails, only this fails and it doesn't fail the entire session. And then you can see exactly what failed and understand it. The second part is how do we even reply production sessions on testing database? Because the context, the state will be different, right? The testing database is totally different. And even if you run it on production, if you collected a session this week, next week the user data is going to be completely different. So how do you even test and make sure things work? And then the third part is how do you make sure your tests don't break on your versions just because of selector? So obviously you write code changes your software, you still want your tests to run. So that's our challenge. We're also very early stage. We have a few ideas, a few proof of concepts. We're actually onboarding our first customers this month. So we're kind of still learning. And I'm also going to kind of use similar to Max if anyone wants to kind of talk through this idea or worked on something similar, like just search for me, Gal at superset.com or Gal and the Superset Slack. But we're going to do take a few approaches. The first one is isolate components. So I talk about state, and state makes it very hard to just reply production sessions in testing. But if we're going to isolate the component under test, so for example, if we want to test the UI, if we're going to mock the backend, and we're going to mock the database, and we're going to mock everything but the UI, it makes it much easier, because when you mock everything else but the system under test, there is less state or context that you need to keep constant, because you minimize your problem, and it makes it much more easy to treat. The second part, we want to find common patterns in user behavior. So if we see that 10 or 20 or 30 users that they go to the login page, type the username, type the password, press login, we're like, great, that's a test. If we see this pattern across a few users, we realize that's a test we need to test. And the second part is API requests. So we kind of assume that when you make an API request to the backend, that's probably either the end of a pattern or a start of a pattern. Again, if you think about a login page, you do a bunch of stuff, you click login, there's an API request to the backend. So everything we saw before should be a test. Everything we see after should be a separate test case. We don't want to run them together because we're testing two things on the same test, and if something fails, you don't really know what failed. And then the last part is learn from production, build on testing. We don't want to build the test from production. We just want to understand how your users use your product. But the tests are going to build on testing database. What I mean by that is you can think about those machine learning models that learn how to play games, right? You just throw them in a game, they start clicking stuff, they fail, and then they try again, they become a bit better, and after 24 hours, they're like really good at playing those games. So we want to take a hybrid approach where production gives us a data set of what are the things users do on your app. But we're not trying to replay it one by one. We're actually going to throw our model into production and into testing, and they're going to try a bunch of stuff. And they're going to see what works and what doesn't and how your software reacts. And we hope that with time, our models don't just replace sessions in production. They actually kind of learn how your software behaves, similar to how the model kind of learns how to play the game. It learns like what actions lead to good results and what actions lead to bad results. So with time, our software wouldn't just reply things from production. It will just know what your users do and kind of reply it by in a more fluid way. So not like the exact session, but let's click a button. Okay, this model opened. Let's see what users did with this model on production. Let's try a few things. Okay, great. Nothing happened. Probably we didn't convert it correctly. Let's try to do something else, use different selectors. Okay, this time it actually happened, and an API request was sent. Great, now we have a test case. Put it aside, next version we're gonna run it. So it's more fluid rather than like record and replay. I guess that's it. If anyone has any questions, I'm happy to take them if we have time. Yeah.
So the tests, the isolate components bit, is it like confined to the UI, or will you be like, do you aim to test services in the backend as well?
So also in the backend, again, it's a startup. You start with a very narrow problem, very narrow product, and then you expand. So we do want to start with the UI. But yes, with time, if we can mock the database, for example, we're basically solving the state problem. Because if we can kind of mock the same queries from the database, we can create a similar state that's what we've seen on production. But we can also isolate in a microservice environment. We can test a specific microservice and then mock all of the other microservices based on what we saw in production. And then again, it makes it much easier because the only thing under test is this microservice, and everything is just a smaller problem. There's less dependencies.
And these generated tests, they are like, in context of UI, is it like Selenium/Cypress tests that will, as a developer, I will get for free when I use this, on my UI?
Yeah, so that's the start. We're going to start with Selenium. We're going to use a different framework called Playwright, but yes, we're going to start by spinning up a browser, mocking up the API backend, and then just start writing tests. And then we're also going to try creating end-to-end tests. So end-to-end tests, you want to create a less end-to-end tests because they're expensive, but they're really important. And then like when you only do UI, you can be more expensive because it's faster to run. And then with time, we'll add, okay, we figured out UI and end-to-end tests. Let's add microservice tests. Let's add database tests. Because this idea of let's see how things happen in production and replay them, this is a very universal principle. Now we just need to find what's the least path of resistance on an MVP level, and then where we can expand it to solve more and more problems.
Cool. That's a cool product.
All right. Well, thanks, Gal. And next up is Elda from Scalera.
Hi. Oops. There we are. All right. So I want to set the context a little bit because you probably are not familiar with what we do at Scalera. We're still a very young company. The analytics team is only 1.5 people, and you're looking at 2/3 of that team. But that doesn't mean that we're not doing some really great things, and we're solving some very interesting problems. So in a nutshell, what we are is an employee empowerment platform that provides knowledge, skills, and data-backed insights that are needed to build inclusive and productive teams. Earlier today, we had a panel where there was a lot of discussion about people skills. That's exactly what Scalera delivers. Okay, and so our clients have their employees. Our clients are household names, businesses that send their employees to our platform, and they go. It's a self-paced, non-mandatory, right, training that people go on their own. And we so far are having really great success with really huge engagement. And the main reason for that is because for the first time, these sort of HR type trainings are providing value to the employee, whereas the typical HR inclusion type training is really meant to be compliance exercise. People just check in the box, right? And so it really doesn't contribute to a better environment, a better working environment. And when we talk about inclusive skills, what we really mean is people skills, right? That's what inclusive skills really are. And so that's the other reason for our success so far, is that we have set up this program. Anyone met Dr. T yesterday? She's the brains right behind this. The way that the training is set and the discussion around inclusion is set up is so that there's no blaming, no shaming, no setting up, okay, this is the in-group, based on demographics, and this is the out-group, and, these people are wrong and these people are right. It's more of a, let's all get better right from where we are, to include everyone regardless of what demographic group they are in. So I'm going to skip to just give you a taste for what we deliver to our clients. We give them a lot of engagement data and as to the different paths and also different, I know it's a little blurry, but for example, we show them from all of the different departments who's participating, what percentage, right? Do we have any highlights or lowlights there? That 73% path participation, that's actually an average in all of our clients. That's how many people participate in our training programs. That's huge, okay? And then we also have created these indices, right? So we went through about we sifted through about 38,000 pieces of published research to identify these 4 pillars: growth mindset, belonging, trust, and voice, as the measures that are really highly correlated with employee engagement and employee attrition. And so we ask questions about, let's say, how much voice do you feel you have in the organization? Can you bring up difficult work questions? Or are unique ideas appreciated? We ask a lot of questions about belonging, about trust. If people knew more about you, right? If self-disclosure is something that people are practicing, do you trust that they wouldn't use that information against you? So this is sort of just to give you an idea of what is it that we do. We also give cuts by department so that companies can tailor their inclusion efforts, right, to the areas that are really problematic. Like, for example, we may see that we've picked on IT, but we may see that an IT trust may be low, and that's like one thing to focus on instead of, sort of a blanket inclusion effort across all teams. Okay, and then we also have these paths that actually give you real skills. We have about 27 skills that we teach people, not just like what is the skill, right, that we're talking about. Like, for example, how to scan a room for who's answering questions, who's contributing ideas, and who's not, and maybe ask someone, I'd love to hear your thoughts about this, right? That is called panning, like panning a room to scan, right? These are real skills, and so we ask people about how many times they practice these skills, right? How many conversations they had about times when they did something, they made a mistake and they fixed it, right? So this is just sort of an idea of everything that we're doing. We also have groups, they meet in groups, and then they share about the company and what are the skills that are most typically used and not used. And finally, we also integrate and work with people analytics teams of our clients to figure out how to triangulate around certain problems. So if, let's say, we have a downward exclusion problem between ICs and managers, right? Maybe they have data on their pulse surveys or engagement surveys that, combined with our information, can lead to a solution. And so, so this is basically, in a nutshell, what we provide. So here's the problem. The whole, I think, one of the biggest innovations of this program is the fact that, and the reason why it's so well accepted and people engage with it is because, again, we are not really putting people into certain demographic groups and then designating them as in-group or out-group. We only talk in terms of in-groups and out-groups, which could be different in different organizations and within certain organizations. So before I got into industry, I was one more minute. Okay. So in the Navy, for example, we have about 20% women, right, and 80% men. So obviously, women are the outgroup, right? However, within the nurse corps, it's the opposite. Females are 80%, right? And so in-group and out-groups are very relative terms. And so now our challenge is, and I come to the problem finally, with 30 seconds remaining, we want to be able, based on all of the answers and how the people navigate through our platform, we want to be able to identify the in-groups and the out-groups. In other words, we want to figure out a measure of polarization within the company, right? Because we may find that belonging is a 7 across multiple companies, but that doesn't really tell us like how polarized certain groups are within the company. The average can still be 7, right? And so we would like to do that not in terms of demographics, right? We would like to do that based on the information that we gather from these people as they go and answer, go through this path and answer these questions. Then the challenge would be to, once we have identified these groups, how can we use human resource and data from Workday to actually test the accuracy? So for example, if our algorithm will tell us the in-group is females and the out-group is males, more likely, right? And then we know that this is a nurse core team, right? Then we would say, oh, that makes sense, right? So we have not solved this problem. This is the next thing. Anyone has ideas or solutions, I'm all ears. And in fact, that's the main reason why I'm here. So thank you.
So something to speak about in after the session in the discussion time.
Yes.
Excellent. Thank you, Elda.
Awesome. Thank you.
So Nikhil from Habu, you're up next. And we're actually going to skip the questions just for the interest of time, and we'll reserve all questions at the end, basically.
Hi everyone, I'm Nikhil from Habu. We're a data clean room company. If you're anything like me, you hear data clean room, you think a janitorial closet or an empty room with a broom. That's not actually what we are. Data clean room is basically a safe space for data to be joined, collaborated, and draw insights with. A quick example I can give you is, let's say you're advertising through Google and you have your own first-party data. How can you join those two without SQLing through all of Google, SQLing through all of your own stuff, and then finding another third party to merge those datas? Well, we're the solution to that. I know originally we've gone through inference and the question and the issue and the solution. I do want to talk about our infrastructure first because I feel like that will allow me to draw better into what our actual issue is. So the way engineering helps us out, we work a lot with Docker as our main kind of analytical modules, and very similar to I think BoomJam and Escalera, we're a data science / data monkey team of about 2.5, 2/3. But we work primarily in Docker to create these analytical modules. We have our data set up within our UI, and the fact that, hey, you were working with Google and Amazon, you can create an API to connect to all that. You have a Snowflake share set up, you can set up all that. We can have our own kind of continuously updating, S3 buckets with our own first-party data, so on and so forth. That's all explicitly made in the data ingestion part. Some UI shenanigans, not relevant. But then the model execution itself is through a Spark job or something, or through Snowflake itself if we're using some sort of Snowflake UDF. But then the model is executed, and then the results are output. It can be a pickle file if you're creating an ML model. It could be a CSV. It can be an HTML. Whatever it may be, it's sitting in a specified S3 bucket. So, seems pretty straightforward. What the issue really is privacy and PII and injecting noise, right? That's a huge topic within security, advertising, cookies. It's all privacy. That's where we're going with this. So the question that we have and our real big challenges are, how do we as a company use a Rolodex of privacy mechanisms for the entire clean room pipeline? And you saw in the previous slide that includes data ingestion, data profiling, what does the data look like, modeling, I'm actually creating the model, some sort of aggregated insights, model output. Every step of the way, it touches different parts of data. Now, this is not an issue if you're working with your own data. It doesn't really matter. I can look at it. My colleague can look at it. But this becomes an issue if I want to partner with other people. So an example I can give you guys, Disney's everywhere, right? We see the mouse everywhere. That's kind of a given. But one of their biggest kind of partners is probably going to be Pepsi. They sell Pepsi products at the parks. We're going to advertise Pepsi products in our Disney Plus shows. So how are they going to combine each other's data? And one of the big issues is Pepsi wants to look at Disney's data, but Disney's not going to allow it. And same thing vice versa, right? It's ownership. That's what really matters. So what we have started being able to build is I'm, as a Pepsi employee, building a model using Disney's data, for example. So now if we want to profile the data, there's a chance that if I just kind of sample 100 people and draw an aggregated mean, and I do it again, and I just remove one person, and I just draw those values out, there's a high chance I'll be able to kind of identify that individual person that I had removed from the data. So there is a plethora of privacy mechanisms, right? There's binary, there's all this stuff for continuous stuff, for aggregated numbers. The issue really becomes, at what point should I inject noise? Should I inject noise when I'm ingesting at the very beginning? So I don't even ingest the plain raw data, I'm ingesting modified PII private data. Do I inject noise while profiling the data? You want to know what my data looks like, how many rows, how many variables, what are the structures? Is that where I inject noise? Do I inject noise when I'm actually creating the model? I have X-train, X-test, all that stuff. Is that where it gets injected? Or is it at the very end when I'm showing you your actual insights? You have X amount of users buying Pepsi products. You have X amount of users buying Coke products from the Disney ecosystem. Every single step of the way has some sort of data. And every single step of the way probably needs some sort of privacy. And it really depends on who's using our product to figure out at what point do you need some sort of noise injected. So what we have kind of found as a solution, and it's very temporary, is we're using Laplace distribution with a mean of 0 and right now we're using a range of max minus min as our second parameter for the Laplace distribution. We're injecting that into our log level data, but then as our noise gets bigger, we can retain key descriptive statistics like mean, but those min maxes are changing. So it becomes an issue of how I want to inject noise, retain descriptive statistics, inject noise, but retain, an aggregated count, and then finally inject noise, but not be able to find individuals that I'm actually targeting. So as far as privacy is concerned, this is kind of our biggest issue. Honestly, I know we're coming from very different things, right? So as always, if you guys have any solutions, I am all ears. But yeah, that's where we're going with Habu.
Food for thought. Thanks, Nikhil. And next up, Ram from Catch.
Okay. So you kind of stole my thunder a little because I was going to start off with a little story. So, and similar to yours, but the solution's a little different. So you're the chief research officer at a hospital, and you've been invited to participate in a cancer study. But it's a pay-to-play game, and what you have to pay with is your data. So you want to share your data with other hospitals and combine to make a bigger study. But you're the research officer. You don't know where all the data is. You don't know what all the contents are, and what's HIPAA compliant and what's not, what's private. So you need help. That's where Catch comes in. Catch has a discovery tool that will look through all your data, identify all the databases, data sets, schemas, tables, attributes. It'll tell you that these are ints, these are character strings and such. At that point, though, you still don't know what's private, what's not, and that's where the classification comes into play. What we need to go is from ints and varchars to this is a first name, this is a last name, this is a social security number. And that's the inference problem that we're at. We're sampling data, and we're labeling it and enhancing the labeling that was there before, in the sense of it's a person's name and their social security number. Okay, so that's the inference problem. We take some sample and run it through this machine. The solution we have is really it's a recurring theme for the last two sessions. It's about creating features. Again, the features is really about standardization of the input to the model. That's what the game is. And so we simulate data, first names, last names, birthdays, and such. And we have a couple of different mechanisms for creating features. One is this n-gram tokenization, which splits the word up into character strings. And the other is using domain knowledge, for example, to say this looks like an email, this does not look like an email. And we combine those together, run it through a logistic regression, and train the model to say this is the first name, the last name, social security number, or nothing at all. So the reason we choose a logistic regression is, one of the reasons is it's fast, it's light. Because this is deployed remotely on our client servers, we're trying to not be too obnoxious in terms of using up too much RAM. And we like it, so we like to be lightweight, we like it to run quickly. So one of the issues that we have, though, is it's deployed as part of a larger application within the environment. So one of the issues that we're struggling with now is if we want to update the model, we have to do a whole new deployment to the client. What would be preferable is you deploy once and then change the model without having to do all the redeployment. So that's one thing that we're looking into. Another is because it's running on the client servers, we don't see their data, and we can't exfiltrate their data. All we see is what the output of the model is, and we get labels. And so, how did we do? And that's really a question that we're trying to figure out now is how to assess the quality of the model. Where did it work? Where did it not work? So there's things that the model does, the parameter, not parameters, but outputs, some more metadata that it has. So if we can get that out, we can then compare it to a golden, data set of what we trained on, So if we think it's a state, in our data set, we have some probability it's a state, but their data set comes back and says it doesn't give us the same probability that we had for state. And so it turns out that there might be a company that is working both in Canada and the US, and so state is actually state and province. So things like that we could try and identify by looking at the output of the model. So some of these things are, we need to get back some of the model data results and then analyze those things as well. And then some of the ideas that we've had over the conversations now, I think would be relevant in terms of understanding where the model's working and where it's not.
All right, thank you, Ram. So I have so many questions, but we'll reserve them later. Okay. So let's go on to Pankaj from Markov ML.
You know what makes me happy today is like all the companies here in the Hive, and they are talking about data, they are talking about algorithms, they are talking about statistics and machine learning, which is great because that's the reason of our existence. Our goal is to make sure that companies like these, A, become successful, B, make their dreams into reality much faster, and then iterate on dreams even faster so that they can wow their customers. So that's what our goal is. Now, how we do that? We do that by creating a system of record and a system of intelligence on data and algorithms for these companies so that they can take decisions faster, they can know the state of their product faster, and they can iterate on it even faster. So there are a bunch of, we are an MLOps companies. And the reason I didn't change my slide because I'm going to show you what we are going to work on. So now we are cross-modality platform. Like we have companies that collaborate with us when the modality is text. We have companies that collaborate with us, the modality is vision, images. We have companies that collaborate with us, the modality is like categorical data. Now, even though we are a machine learning platform, machine learning is at the core of Markov ML. So I'm going to go through a problem that we recently solved in the vision domain. So one of the problems in vision, like one of the things we do, as I said, we have system of record and system of intelligence. System of record means if somebody has to find their data, model, intelligence analysis, they come to Markov ML and they can search for it. Like first, the discovery, like do I have the data? The second part is intelligence. When we talk about intelligence means knowing your data. So that you need to have that intelligence to be able to build upon that. So for example, let me take the example of Spectrum. So they, for example, have a lot of data coming in. But in order to train a model, first thing they have to figure out if this data is actually the type of data they can train a model on. For example, if it is a romantic movie data, they can't actually train a hate speech classifier on top of it. Right? So first, knowing data. And this data is indeterministic because there's so much volume coming in, it's very hard to know. So system of record means this is the data. System of intelligence means, is this data relevant for you? So in this case, in the image thing, we have a lot of images coming in. These are the data sets that a customer might have. And what we want to understand is this data set relevant for the kind of problems they are solving? So the intelligence layer on this is these detections of different objects over the images, if that makes sense. Okay. So now the problem specifically that we are trying to solve is the modality of images is different. And there are, it's very hard to detect objects in images because they may be occluded, they may be overlapping, and they may be cross-domain. So in this case, the state of art right now is YOLOs. You only live once. So the most recent one is the YOLO 6. But they are very domain-specific and have been trained in large corpus of data. So how can we leverage this information? If you take just YOLO for weapon detection, it will detect only weapons. If you go and find YOLO, which is detecting heads, like human poses, you'll only detect heads. So how can you combine this information? Right? So one way is you go and kind of create a training test set which blends these two together, label it, and go ahead. But obviously, we are not going to go in that direction because A, we don't have resources to do all that, and the amount of data required is humongous. So what we did is created a blender model, which we call Markov Blender. It takes cross-domain data, blends it together into the result. So this is the end result for the blender. So how we do it is we take all these images, and we have trained a domain-specific classifier. So domain-specific classifier outputs probabilities of a specific thing belonging to a domain or not to a domain. We take these probabilities as if they are generated by a sensor. These are weights. Like these are the sensor output values. So these sensor output values are actually fed into another classifier called the sparse-max classifier, which kind of outputs what is the likelihood of this particular image belonging to one or more domains. So it kind of suppresses, if you know about the L1 normalization, people here, it kind of suppresses certain weights which are not relevant for classifier to make predictions. It reduces the overfitting problem. So what we do is we fetch it through a sparse-max, and the sparse-max gives us certain weights. Then we run it through different YOLOs. And these YOLOs are now detecting these frames. Now when they detect these frames, we kind of blend them together through the blender, and the labels, which are non-domain specific, where the domain weight is lower, those get eliminated. And the end result is the result that you saw here. This is as simple as that. Now, with this approach, what we need is we still are able to take the greatest and latest YOLOs. Only thing we have to do is actually go and train these domain-specific classifiers. And the pipeline is kind of decoupled from the actual problem, and we can work across multiple domains. We don't have to go and train data. We don't have to go and train YOLOs for different domains. So how we track it is using Markov itself. So we dogfood our own food. A lot of the things here are either in progress or are already in production. So for the data access and store, we have Markov obviously as storage, which saves a lot of the information in any of the blob storages. We have a training tracker, which tracks all your trainings, what is happening in the model. All the hyperparameters, all the loss functions, what is the state of your training. All the information is logged. We have a model registry, which kind of registers all the models that have been trained using the platform, and then an evaluation framework that helps you evaluate this model, compare it against multiple models across multiple data sets, and kind of generate reports which are explanatory and also guides you in the direction, like are you actually trending in the right direction. Then we have an analyzer framework, which kind of takes these models and tries to infer like how similar or dissimilar they are. If you launch this model in the production, which are the segments that will be impacted positively or negatively, so that the people who are in charge of business can make decisions. And the last state is the testing, which we basically go, and we have an integration testing that the pipeline built in to make sure that your models are still compatible with your existing framework and existing pipelines. The challenges, again, are the cross-domain. Label data is still a problem, because if you want to go to domains which are not supported by YOLO yet, then we don't have it. Compute is expensive, so continuously we are working on improving the compute. And testing this is a very complex architecture, like making sure every bit and piece is working across multiple modalities. It's a hard problem. And obviously, humans, like finding people to work on these problems is always hard. So we have been lucky so far, but it's going to be a continuous challenge. Thank you. That's pretty much it.
So we have about 10 minutes to go through two talks. All right. So Devanshi is next from Spectrum.
Hi everyone. I'm going to talk about what problem we are trying to solve at Spectrum and how the engineering processes at Spectrum help our data science processes. So there are billions of users on the internet every day, and although there is a very tiny percentage of these users that are bad actors or who have toxic content on different social media platforms, they affect quite a large percentage of people who are actually clean, who use social media for a good purpose. So at Spectrum, we work at detecting these toxic behaviors from user-generated content and try to safeguard the online communities. What is this toxic content and how we are detecting it? Toxic content could range from anything as simple as posting a very hateful message on social media to something that is as severe as child sexual abuse material. So how do we solve it? We have deep learning models, which in pair with a set of rules, give the detection of whether a particular behavior is detected or not. So it's a simple 0-1 problem, but much complex in terms of how it's detected and the various challenges involved. Trigger warning for the next section. What are the various challenges that we face while solving this data science problem? First of all is the user-generated content itself. Since the text is user-generated, it could have many things, like length of text could be variable. So for example, people talking on a gaming platform, the text is going to be very short. People are going to abuse each other and while playing a game. While on a dating platform, the content is a little longer, but it is descriptive and stuff. So that is one of the challenges, to detect toxicity in very short text versus very long text. The second is lexicon alignment and labeling. So lexicon alignment and labeling is one of the major challenges that we face today, because although the problem is a merry 0-1 problem, but there are different kinds of behaviors that we are trying to identify. So every behavior, like sexual, insult, profanity, hate speech, they all have a set of definitions which say whether that behavior is satisfied for that criteria or not. And then labeling that data, we heavily rely on labeling today, and labeling is very expensive. One, in terms of training the labelers to understand the complex definitions of these behaviors, and two, finding labelers who are multilingual. So we have to find native speakers of different languages because we support multilingual detection. So it is hard to find those kind of labelers. Third big challenge is domain-specific customizations. Since we support different kinds of platforms like gaming, dating, e-commerce platforms, the kind of data that we see and the kind of solution that we want to give them is a little different. So for example, a person threatening another person on a dating platform is a clear threat. Someone saying, I'm going to kill you, is pretty threatening on a dating platform. While on a gaming platform where it's a violent game and people saying, I'm going to kill you in the next round, it doesn't really mean anything on a gaming platform. So there are different levels of customizations that are involved when we solve this problem for different kind of platforms. And the fourth one is data availability for low resource languages. As I mentioned, we support multilingual content and detect toxicity in different languages. It is very hard to source toxic content, which is in low resource languages. It is pretty easy to find English content because all of these social media platforms have most of the content in English. But for other languages like Japanese, Chinese, Korean, it is hard to find toxic content. It's easy to find clean content, basically. And the last biggest challenge is language identification. As I mentioned, that user-generated content can vary across platforms. It is hard to identify language. We have our in-house language detector, which detects language of text, but it is very important to take into account the different kind of text. For example, the nature of text, the style of different people writing different things, and then there is code mixing involved where people are talking in different languages at the same time. So these are the various challenges that we face. Now I'm going to talk about how our engineering processes help the data science team make our work easier. So this is the kind of timeline that a text message or a text goes through from when it is inputted into our system to when we give the output as a detection of this is hate speech or not, this is sexual or not. So the first step is data ingestion. Deep learning models do require lots and lots of data to be trained on. And the engineering processes that we have, they help us to very easily sample a lot of data that we can then label and use for our training. And data gathering is once we have all the data labeled, how do we gather it in the most easy way so that it takes us the least amount of time to train that data, train the model. Second is text pre-processing. We have multiple text pre-processing strategies available, ranging from something like, I want to use the simplest raw text that the user has written, to something as complex as, I want to remove all the punctuations, I want to remove all the lead speak related things, like I want to change the 0 to an O, I want to change the 3 to an E. All those complex text processing techniques are available, which help us enhance our processing. Reproducibility, all our models, data, everything is versioned, which helps us to reproduce things that we have created or built even months ago. So versioning is one big thing that helps us a lot. And then DS-Dev integration, all our solutions for different clients and different behaviors are built by the data science team, but the maintainability and easy updating of those solutions is where engineering comes in. They provide us interface where we can very easily update on our solutions regularly. And then the last thing is testing. We have two types of testing. One testing that we do on data science end, and the other testing that the dev team does on their end. So in data science testing, we have a pipeline built by the engineering team, which helps us save a lot of time in testing all our solutions. And then the dev testing is where they provide us one-click support to do smoke and regression testing, basically to check that this is what is going to look like when the client is going to see the text, and this is how the detection would look like for them. But yeah, this is it.
Thanks, Devanshi. And then the last contribution of the session that will go until we get kicked out, basically, is Sabino from Sturdy. So Sabino.
I'll keep talking until I get kicked out. So Sturdy, so the company Sturdy exists for about 2 years now. It was founded by the people who founded Sturdy. They really got the idea of Sturdy with the last company they successfully built up and then sold, because they always felt like they needed a tool like Sturdy when they had a company. So the idea of Sturdy is the tool is analyzing. I actually put the superset words here, capture, analysis, activate here. So what we are doing is turning customer feedback into insights, and we automate them to the people that need them. So to unroll this a little bit, so we work with business to business in the business to business space. So we take all the customer feedback that our customers get from all the types of sources. You can think of Salesforce, email. We are working with Zoom transcripts, all types of data sources, all in the form of unstructured text exclusively. So we don't really work with structured data, all unstructured text. We take all the data in from a customer, and then we infer what we call signals. And it's kind of similar to like what you saw on the last slide, except that we have 15 different types of these signals. Now, we are not just detecting hate speech. We have 15 different types of customer signals, all trying to identify different types of relationships between a business and their customers. And for example, churn is one when we detect that a customer is likely to cancel. We detect when they talk about bug reports, when they talk about training requests or how to feature requests, security, and lots of other ones. And this is all done through supervised learning, similar to what we had seen in the tutorials. Data labeling, lots of a big effort there to train all these signals accurately based on text. But then there's a second level that we're currently working on. Actually, I think we are rolling out the feature today. Unsupervised learning. This is trying to drill down into these signals. So what is actually going on under bug reports? What are the top 25 bugs a customer typically has currently in the last 30 days? What are the most talked about training requests so that the customer can start focusing on them and trying to maybe improve the help, things like this. And this is all done through unsupervised learning, similar to what we had talked about in the unsupervised tutorial. So the biggest challenges really are on the capture side. Well, yet another integration. We are currently integrating with another tool. So every time a customer brings up a big data source that we haven't seen before, our engineers have to integrate with that. On the analysis side, text is a mess. The text we have, you can think of these sometimes month-long email conversations and trying to identify everything that's going on in there is really challenging. So we don't have just like a Yelp review of 50 words or so. It's really long, challenging text. And then on the Activate side, since our tool it's not just a recommender system like Netflix, for example, where you use a tool and you look at it and you can decide yourself if it's good or bad. Since we have automation built in, which is really trying to push data back to them about the signals into like the systems they work with, for example, Salesforce. The signal to noise ratio or false positives is a big challenge for us, because I mean, like anytime you work with systems that push stuff to people, if you push content to them that's not relevant all the time, they get pretty quickly bored with that and might turn the system off. So that's our biggest challenge there. I can skip the next slide here because I think we are running out of time. The next slide I was kind of struggling with that anyway. When I was thinking between the interface between engineering and data science, it's probably easy to say where the engineering team doesn't work with us. I think like bringing models to life, for example, I think nobody actually talked about that. But if you think about the data engineers, I mean, what are our models with all the front-end engineers and all the people putting all the effort in to make the models look cool to the customers? Security is important. Data labeling is a big one for us, and we actually let the customer label too. So we use, on the data engineering side, the production UI to label, and the customers can actually label too, which is kind of interesting for us to see what they are doing. Anyway, that's it.
Well, thank you, Sabine. So we are like 2 minutes in the next session, so I thank all the speakers, and we will reserve the questions to the coffee breaks and the dinner later on. But thank you all.